So everybody able to see the PowerPoint? All right. So this is on a two-step method for faculty hiring voting. Now, voting theory has been around for hundreds of years, studied by political scientists and mathematicians. But their main goal is to find a single winner of an election. When you're doing a faculty search and on a hiring committee, there are more possible outcomes. You could have a winner, and while it's not desirable, you could have no viable candidates, in which case, you have a failed search, have to try again later. You're also often not interested in just the winner, but you're interested in maybe, is there a second or third choice in case your first choice ends up taking a different position? So the assumptions are kind of different from some of the fundamentals used in math and political science. But by borrowing a couple of their methods, we can still put together something that meets all the needs of a hiring committee. And the first step is to use what's called approval voting, where each person on the hiring committee just marks each candidate as acceptable or unacceptable. No ranking, just whether or not that voter believes the candidate meets the minimum qualifications to be suitable for the job. And then the second step will be ranked choice voting. So in approval voting, each voter is given a ballot with all of the candidates, and they just select, is this person qualified for the job, yes or no? So a ballot might look something like this. If you had a bunch of candidates competing for a position, each voter would just go through and mark each candidate that they believe is qualified for the position. And once you do that, here's kind of a hypothetical situation where we have a committee of 7 voters. And if we look through here, voter 1 approves of candidates A, B, C, and F. Voter 6 likes candidates A and F. Voter 7 doesn't like anyone. And what we look through are each candidate, how many people approve of that candidate. And in this case, the first possible outcome is, notice out of 7 voters, there is no candidate that the majority of people approve of. So this would indicate you have a failed search, that you've looked at candidates and there's no one that the majority of people like. It's not the best outcome, but it is something that can happen in a search committee. The second option, different set of votes. Here we have one candidate only that the majority of people approve of. So this makes the decision kind of easy. If there's only one candidate that everyone, or that the majority of people like, then we're done. We offer that position to candidate C, and we hope that they accept, because if they decline, none of the other candidates are suitable backups. So that part's pretty straightforward. Now where things become a little bit more challenging is multiple candidates. So here we have candidates A, C, and G all pass the threshold. So all 3 of these are viable candidates. So now we have to go on to step 2, where we issue a ranked choice voting. So this would become a second round of ballots, where we'd say, okay, now out of candidates A, C, and G, rank them from your favorite to least favorite. And with ranked choice voting, there are a lot of different ways to analyze this. This is something that mathematicians and political scientists have looked at extensively. There are things called like board account, plurality runoff, Hare, Condorcet methods. These are all different ways to score ranked ballots. In this research, I chose the board account because it favors candidates that have broad support. Some of the counting methods focus mostly on first place votes. And that would allow for someone who's a very polarizing candidate, like 51% of the department love this candidate, 49% absolutely hate. Some of the methods would allow that polarizing candidate to win. With the board account, it would tend to favor someone who's maybe like second place across all members of the committee. And that becomes valuable. And by the way, this is the part of the research I'm still exploring a bit, that there is literature out there that talks about in a variety of disciplines that for employees to succeed, they need kind of a broad support from their colleagues. So board account tends to favor candidates that are kind of accepted by everyone, rather than someone who's maybe more polarizing. And the way the board account works is first place votes are worth n-1 points, second place n-2, and last place are 0 points. So the basic scoring would work like for candidate A, here are the ranked ballots. So here's 1 ballot, 2 ballot, 3, 4, 5, 6, all the way down. Candidate A gets no points from this person, no points from this person, 2 points here, 2 points here, so they're up to 4. 1 point here gets them to 5, nothing, 6, 7, and 8 points. Candidate C gets 1 point here, 2 points here for 3, 4, nothing, 5, 6, 7, 8, nothing, 9, and 10. And lastly, candidate G gets 2 points, 3, 4, 5, 6. So now we have all the candidates scored based on where they appear in everyone's ranked choice ballot. So what this tells us is that candidate C wins the election, so to speak. They are our top candidate for the job. But what this also tells us is that our second choice, the second most supported person, is candidate A, followed by G. So basically, you could submit a recommendation that we would like to hire candidate C. If they decline, we would like to go to candidate A. And lastly, G is our last acceptable candidate. Now, this method, if there's an even number of voters, can lead to ties. Because not everyone has, depending on your university or department, hiring committees can work differently. Sometimes it's a sub-chunk of a department. Where I work, we have a hiring committee that kind of weeds out some of the candidates, but then for the final voting, it's our entire department. So there may, if that's something you work with, there may be a chance where having an even number of voters is unavoidable, if there happens to be an even number in your department. So in that case, there are situations where ties can occur. So the important thing is, if you're working with an even number of voters, before you start this, it's good to have tie-breaking rules in place. And conventionally, it tends to be something like either letting the chair of the hiring committee or the chair of the department be a tiebreaker. Because in the first stage, if you have an even number of voters, notice here that candidate B clearly moves on because everyone supports them. But what about candidate A? They have exactly 50%. So you have a tie, so to speak. Or when you're doing ranked choice voting with an even number of people, if 2 people prefer A to B and the other 2 prefer B to A, you again run into a tie. Now, if you had an odd number of voters, these situations can be avoided. But if you're going into this with an even number of voters, it's important to recognize that ties can happen, and it's best to kind of establish what to do beforehand. Right. And there are my references and questions. All right. Thank you.
Great presentation. Well thought out.
All right, thank you.
If there
Yeah,
aren't any,
question. Yeah. What made you interested in the topic? Why did you research on it?
So I'm a professor of computer science and mathematics, and I actually teach a math for liberal arts course that covers some of these methods individually.
Okay.
And then I was in a hiring committee, and they were trying to vote on candidates, and we had kind of a convoluted system where they'd ask like, who's first place, and they'd like hold a vote to see if we want to try a second place, then they'd hold a vote for second place. then they'd hold a vote to see if we wanted third place, and then vote for third. So I was like, okay, there has to be, we have to be able to do this in fewer than like 5 passes. So I
Right.
looked at the existing methods and tried to merge them together into something that now we can get it done in 1 or at most 2 steps.
Wow, that's nice. Thank you.